Hi everyone, hopefully you can see this. If you can't, then shout up. I will get started. We've got, thanks Adam. Yeah, we'll probably keep getting people joining us as we go, but that's fine. So welcome to UNIMAKER, well done for making it this far. Sometimes it's harder to navigate the technology than it might have been to navigate the M1 to come up here. So as I say, well done. My name's Pete Mylon. I'm the conference chair. So this is our second UNIMAKER. Last year we ran an in-person conference here in Sheffield, and we were sort of planning to expand that this year. Obviously things have changed, but it's great to see lots of you joining us online, and actually that's giving us more opportunities to see people that we might not have done otherwise. So you can see this was as of sort of last night, where people are joining from. I've seen in the comments we've got people from Turkey. I'm disappointed that we've so far not got anybody based in Australasia. Adam's going to have to sort of represent from the UK, but yeah, it's become a really sort of international conference this year, which is really exciting for me. Okay. So first of all, a few notices. So housekeeping, there's no scheduled fire alarm test. If the fire alarm sounds, you've probably burnt the toast and don't look at me. The Blackboard link is going to be the same for all the sessions. So if you've managed to get in here now, whether or not you signed up for whatever sessions you signed up for, if you suddenly think, oh, actually, that one looks really interesting and I didn't sign up, it's all going to be in the same place. So just come back to this Blackboard link at the right time, and you should find it. If you're going to share with others who haven't joined yet, it would be helpful for us if they can register via the website, rather than just sharing the Blackboard link directly with them, just so then we can pick them up via the Eventbrite and everything. So in terms of the agenda, this is on the website, so hopefully you've all seen this, but so we've got a 2-hour session now from 10 to 12, then you've got a bit of a break to get lunch and do some work or whatever you're doing, and then we'll come back again for another 2 hours this afternoon looking at co-curricular and extracurricular making. Then tomorrow we're starting off in the morning with what we called a knowledge exchange session. So for those of you who were here last year, we had a session where we talked, we sort of had a bit of a round robin. You could go around and talk to different students and other staff about various different topics. So we'll have that kind of thing again, hopefully, if we can get all the breakout rooms working nicely. And we'll also have a bit of a kind of panel discussion about particularly around COVID-19 and kind of what we're doing. I suppose think of it as a bit of a support group, really, of how we're going to get through this semester and hopefully do some good things in the situation that we're in. And then we've got some, we've got more sessions. So tomorrow there's an afternoon session, and then straight after that there's an evening session. We've got some really exciting speakers in from North America, so to be kind to them and not drag them out in the middle of the night, we've put that session on 5:15 till 7, but that's going to be really excellent. And I hope that you kind of feel able to hang around then and eat your dinner while you're watching, or hang on until afterwards. So that's it in terms of the agenda. Okay. In terms of the talks, they'll be recorded. Hopefully this is being recorded now, and we'll then put them up on the website afterwards. Yeah, it says it is being recorded, so that's great. Yeah, we'll get those up on the website, probably on YouTube or somewhere nice and accessible as well. So anyone that hasn't been able to make that should be able to catch up. There'll also be some other pre-recorded content that we'll make available as well that we didn't have time to sort of fit in the agenda. So look out for that. Yeah, please do use the chat. People seem to be doing that, which is great. We do want lots of participation, although, you know, during people's talks, do try not to kind of take it off on a completely random tangent, just to help the speakers and help people to kind of keep focused on those. But yeah, otherwise, it's, you know, that's your kind of opportunity to network. So please do use that. You can also use private chats if you want to network with individual people. The Blackboard session will be open the whole 2 days, so you should be able to just stay in here in between sessions and chat on the video or via the text chat if you want. If you've got a question, you can raise your hand. So there's a little button here at the bottom, which hopefully you found. We'll try and do sort of Q&A after each session, but if there's somewhere, you know, if you really need to sort of interject at that point, then yeah, just if you can do the sort of raising your hand thing, hopefully the speakers will keep an eye on that as well, and then they can come to you and unmute you. If the rest of the time you keep yourself muted, it just means we don't get loads of background noise. We should be able to mute you again. We can't, the moderators can't unmute you, I believe. So once you've raised your hand, if they do come to you and say, yeah, you know, what was your question, then you'll have to unmute yourself and try and remember to just mute yourself again once you've finished. Okay. Yeah, it'd be really great if you can share about UNIMAKER. So we've got the hashtag UNIMAKER20 on Twitter. There's a LinkedIn group. I was going to put the link in, but it's easiest to just go on LinkedIn and search for UNIMAKER. Hopefully that'll be a good sort of community for people to discuss as well. And you can follow me and the Sheffield Uni Engineering. We'll be posting lots of stuff about UNIMAKER as well. Okay, so before we start, just a little tribute. Those of you who joined us for UNIMAKER last year may have met Pete Brownhill. Pete was the principal technician in the School of Creative Arts at the University of Hertfordshire, and was an expert model maker who actually came from Sheffield originally. After coming along to UNIMAKER last year, Pete went back and set up a really popular makerspace at the uni there. And because of his enthusiasm for making, we invited him to help us plan this year's UNIMAKER, and he gladly accepted and became a really key part of the team. I really enjoyed chatting to him about all the amazing model making projects he'd been involved in and the fun things that students were doing in his classes. But sadly, as we were preparing to move online this year, I found out that Pete had passed away in June after a very sudden illness. Looking at the tributes online, it's clear that Pete was much loved by staff and students, and he'll be sadly missed at UNIMAKER this year. So lastly, I hope that this conference gives you a chance to exchange ideas with like-minded people, gives you some space to think about making and how you're going to do it in the current context, inspires you with some fresh ideas from all of our great speakers, helps you to build that community for support, which I think at the moment is particularly pertinent, and helps us to get many more student-led makerspaces around the country. So now I'm going to hand over to Professor Tony Ryan. Tony leads the University of Sheffield's programme in sustainability research across pure and applied sciences, engineering and social sciences. I've had the privilege of working with him on PPE over lockdown, which he's going to talk a bit about, so I won't give any spoilers. But Tony's a professor of chemistry, a former Pro-Vice Chancellor at the university. He works on a huge variety of projects, mainly around global food, water and energy challenges, and as well as being a regular contributor to TV, radio, national press and at learned societies and even the UN Climate Change Convention. he was awarded an OBE in 2006 for services to science. So over to you, Tony.
Great. Thanks, Peter, and glad to be here. Let's see if we can get the sharing working. So can you see the first slide? I'm taking that as a yes. I can't hear anyone. So, yeah, as you heard, my name's Tony Ryan. I'm going to talk about refugees making the desert green. Why am I here? Well, I run the Grant Centre for Sustainable Futures, and I have a track record of building things and doing art science collaborations. So I ended up in the Zatari refugee camp about 4 years ago, and I took a group of scientists and engineers back with me to do a scrapyard challenge. And then when I started working with Pete at the beginning of lockdown, I discovered that we were making. So Helen Story took me to visit Zatari in July 16. I've worked with her for a long time on art science collaborations, and she made a dress out of a UNHCR tent, the iconic kind of refugee agency tent, and the dress went to the Science Museum, it went to the House of Lords, it went to UN headquarters in Geneva, and then to New York for Barack Obama's last ever speech to the UN. And they asked her to go back to the refugee camp. So she said, well, I'm a dress designer. I'm not going to be much use to you. Can I bring my scientist? So I'm going to show you a little film now, which is our experience in the refugee camp. The motto of the University of Sheffield is to discover the causes of things. The way to take advantage of knowing the causes of things is to solve them out.
Sheffield University have a great commitment, not only in terms of teaching, but also transferring the knowledge.
We need to get out there and what we've learned to people who need it the most.
This is the second time the team's been here, and coming back builds so much trust. And because we've built the trust up with the team here, they've been able to ask us to do specific things with them to get more kids to schools. We've been able to build a trailer to go on a bike that will be a school bus, and that has been completely co-created. The original idea worked, but not well enough, and then the locals really helped us rework it to make it a great solution.
It's very important for the refugees to grow their own vegetables because they used to do it in Syria.
We showed them the first time how to grow things in polyurethane foam, came back to find they'd already built a farm. Just needed a few finishing touches to make it really sing locally.
The plan is for this project to be implemented within the entire camp, to have several prototypes built, community members running the systems. They all have basic knowledge of engineering things. They know how to make things and build things, and then the parts which they don't have, they just make out of nothing.
Yeah, keep on hearing that word making.
Disabilities, looking at making walking frames for children with cerebral palsy. We worked on the wheelchair.
One of the ideas was to build a specially adapted bike, so the hand cranked bikes, and the people who can't use the legs properly. With a few pointers, they just went ahead and just built it. So the plan for potentially is to build more of these bikes for people with disabilities.
So when I came last time, they were really interested in how they could power their mobile phones, working with the dynamos from the bicycle, looking at what we could make from the recycled polymer they collect. We're going to take some samples from them and reprocess and make something simple like a flower pot. That would be a great achievement, because then they could probably do that here. So a lot of what we're trying to do is not necessarily make a complete finished thing, but give them the skills to say, that's how you do it.
We came over this time to look at helping with weatherization of the caravans.
They are collapsing, there's damp in the floors, and we're keen to move forward with working with them on projects like this where we can share the additional knowledge that we may have.
This visit, I also brought some social scientists who study governance, entrepreneurship and innovation, so that we can all work together with partners in Jordan to achieve the end goal of improved lives for both Jordanian citizens and refugees. So we'll be doing joint research projects around food, energy, water, livelihoods.
We're determined not to parachute in, interfere, dive out again. We really want this to be a sustainable relationship.
Academics really think about things, they really want to solve problems, and it's great to see their minds getting pushed to work on something which is so far outside of the norm for them.
So there are opportunities for our academics to look beyond the camp and to try and understand what is happening to Jordanian society.
It is important that university students get involved in this sort of thing, implementing the sort of gap between academia and the work we do in the universities into a practical application. There's something to be said about just implementing the technology, getting the things you learn about and that out there and expanding the knowledge.
If you read the history of Sheffield, it was set up by penny donations. And to me, that makes Sheffield special. And knowing that that's where Sheffield comes from makes me feel that that's what Sheffield should be about. It should be about helping the people. The people that built Sheffield University would want us to do this.
By helping the refugees is part of our goal and of part of our job.
The ideal situation would be to have essentially two funding streams. So one funding stream so that we could fund interventions and working in camp without needing to bother about the academic research activity, and just use the skills of the people that come from the university to work in this project. When we're working here, the things we do allow us to co-create, so we can learn what it's like for people to live how we might have to live in the future. Making life better for everyone wherever they are is what we do.
Now I have to find how to get back to my PowerPoint presentation. There we go. So I wanted to play that because it's a well-made film. It shows you the variety of things we've been done. And the way we played it was, you know, we went in there to meet all these people who were innovative. And as you can see from the photos, they make use, everything gets repurposed. The bikes come in from the Amsterdam police, they send a crate of bikes. And that's actually a fabulous resource for making things. So the first time I went, and this is a picture from the first time I was there, when we were talking about making a trailer to take kids to school. So we had bikes and we had tent poles, and we, as you saw, we had access to welders. And you kind of saw the second prototype bike trailer in the video, and then kind of I didn't go back, but Aldous did, and found that the the trailer had been upgraded. Now it was all, you know, it was a Surrey with a screen on top, and was ready to go to take disabled kids to school. And you can see in the background the repurposed material that was used to make the greenhouses. And the project that really stuck, and we've been in and we've done lots of things, and you kind of have to find the right thing that captures people's interest, that can be made to work, that has wide applicability, and hydroponics really worked. So the first time I was there, you know, they took me into this warehouse. There was all these mattresses, and they said, we don't know what to do with them. And as you'll see in a later movie, I exactly did. So in 2008, I had an EPSRC project just before I went off to be a Pro Vice Chancellor and drive a desk and a spreadsheet, about making green roofs using polyurethane foam as a synthetic soil. And synthetic soils use hydroponics, so they use the water to do the work. And the growing media is just there to hold the plants upright, and the nutrient solution provides everything that the plant needs to grow. And 2016, Harry Wright started as a PhD student, is just about to submit his thesis, designing really high-tech foams for commercial use in hydroponic horticulture, making them hydrophilic, hold the right amount of water, buffer the ions and the like. So he grows all sorts of plants in polyurethane foam, in special polyurethane foam. And what we had to do is we had to work out how to make the mattresses repurposable. What could we use a foam that wasn't designed to grow plants in, to grow plants? So I fetched some home. As you can see, it's the same piece of polyurethane foam as was on that desk. We started growing tomatoes in it. You can see they've gone out to a full plant with fruit. The root system's looking really, really healthy. The roots are nice and white. The foil's there to protect them from the light. They get all the nutrients from the fluid, and we can harvest fruit, which we then tested to make sure that it was safe to eat. Then we went back to Zattery and found that, like it showed you in the film, they'd built their first racetrack thin film hydroponic system. And as you can see from that photo, absolutely everything in there, the materials are on their second life. The only new stuff in there are the plants. So the pipes are recycled drain pipes, the foams are recycled mattress, the frame of the greenhouse is tent poles, and the roof is a recycled tap. So everything is built on that kind of scrap heap challenge principle, and you can see the scrap heap through the window. And then we trained the trainers. So the fellow with the thumbs up is Abu Wazam, and I get a photo, I get a WhatsApp from him. Well, Moed, who's the guy in the black jumper, in the black jacket, is a University of Sheffield employee, and he spends time working with the refugees. He's a Syrian refugee himself. Helen Story in the picture is my artist colleague, and then the others are based training the trainers. And it turns out that Abu Wazam was our secret weapon, because he was convinced as a Syrian farmer that you could grow things in foam, and he then convinced everybody else. And in doing this, we discovered what co-creation really means. So you can see Harry holding up a plant kind of in a polystyrene cup. Again, a second life polystyrene cup with second life foam growing new life, in this case, spring onions. And we get all sorts of kind of fantastic things sent to us. So part of Syrian culture is mint tea. And having green around is really, really important. And they're not allowed to grow anything in the ground. So this allowed people to start growing things in their homes. So this fella had repurposed a pump from hand soap pump dispenser, a yogurt pot with a piece of foam in, and his mint plant. And so every time he took a piece of mint to make his mint tea, he pushed the pump to recirculate the fluid. And it's these kinds of innovations, bits of ingenuity that make this project really, really sing, because we've learned more about how to do hydroponics in harsh environments from the refugees than that little bit of knowledge that we gave them, that actually you can use a piece of polyurethane foam to hold your plants upright and dip the soil in nutrient. So, like I said in the film, I was looking for 2 funding streams for this, and now we actually have a funding stream for the green beds separated from the research. So we ran a Just Giving campaign, and I'm going to put it in the chat, where you can help fund our work with refugees in hydroponics. And we now have hydroponics going in 2 refugee camps in Jordan, in a number of Jordanian communities, and also with Syrian refugees who are living in Izmir in Turkey. And there's all, you know, endless things. I also almost need a new WhatsApp account for the number of pictures I get sent. So one day I got a WhatsApp message just before we went saying time to harvest the lettuce. So they collect the lettuce. Here's Abu Wissam and Maya taking the lettuce around to Ali, who runs the falafel shop. So Ali's kind of getting a delivery of lettuce, and he makes falafels. And the best thing about this research project is, especially for a fat guy like me, it's a research project that you can eat. And these are the best falafel wraps I've ever had in my life. I don't know whether they're our tomatoes, but they're definitely our lettuce in there. So they grow all sorts of things. You'll see a bit more about the chilies, and they do all sorts of sweet things to kind of put a smile on my face. You know, when they pickled the chilies, they pickled them in repurposed PET bottles, and you can kind of pull a chili, an individual pickled chili, out of your PET water bottle. This caught the interest of this project caught the interest of the BBC. I'm going to do another film. This was on the BBC programme Inside Out.
Zaatari refugee camp in Jordan. It's hard to get a sense of the scale of this place when you're in amongst it, but about 80,000 people live here. So this is essentially a city that sprung up in a very short period of time. The world's largest for Syrian refugees was first opened in 2012 to give shelter to people fleeing the violence of an ongoing civil war.
We thought it would last for a month or 2, the maximum year, but it continues until now.
We could all end up living like this, you know, as climate change plays out. Who knows what's going to happen?
So researchers from Sheffield University and the UN Refugee Agency have formed an unusual partnership to make this desert city sustainable. They want to give people the ability to grow their own food here in the camp.
The areas here are so small and the soil is so salty, and we have not enough water to feed them and feed the plants as well.
About 80% of the people in the camp were farmers, and they farmed land in Syria, and here the soil is so poor that they can't grow anything. So that's what this project fundamentally is about.
The first time we came, it was all about how can we deal with all this stuff? Everything gets reused and repurposed, you know, nothing gets thrown away. It turns out that what they thought was a problem was the way to make everybody their own garden in the refugee camp. There was like literally a warehouse full, and it was oh, we don't know what to do with these polyurethane foam mattresses. and they've got to be disposed of somehow. There was no disposal mechanism. And I just started a PhD student working on how to grow things in polyurethane foam. So I sent the most excited text message home. I know exactly what we can do. We're going to be able to grow stuff all over. We'll be able to turn these beds into green beds, and everyone can have their own garden. I've been to a landfill site and seen a tomato plant growing on an old sofa.
Really?
Yeah. And that's why I knew it'd work. So here we are, we're underneath the car park at the University of Sheffield. Here's some foam in a box where we can make any atmospheric condition, any temperature, any weather.
The whole system is based on hydroponics, growing plants without using any soil. Instead, you use water with all the nutrients dissolved in it.
Foam just holds the plant upright. All the other functions of the soil come from the nutrients in the water. And the beauty of hydroponics is it makes the best use of the water. So you can use 20% of the water that you'd take to grow something in the ground because the water's not running away. It's being kept where it's needed. The challenge is, if you're a farmer that's used to growing things in soil, being asked to grow things in foams, a big ask.
Say hi.
It was taken up by Abu Wazim, and he made it work. He then became the ultimate advocate because he is a Syrian farmer, and the other Syrian farmers believed him.
Oh, wow. He's taking us for the hydroponics.
Amazing. Look at this.
This is the hydroponic system.
So lush. They call you the green hands man. Can you tell me why that is?
Because everything man prays to the god, it grows and bears fruit. Back home, as a farmer, obviously I lived among plants and trees. When we arrived here at the camp, it was in the desert. I was surprised when I met the scientists and they explained to me about hydroponics. I was so happy. I started practicing it, and now my daily job is to come here every morning. It's a lot like my job back in Syria.
Look at this. This is just one of the plants, and there's a whole, I don't even know how many are here, hundreds. And whole coffee cup, bit of foam, there's the old mattress, and that just pops in there so it can get all its nutrients. It's amazing. Everything's recycled.
Today we're going to teach a new group of people about the hydroponic, and we're going to apply things with them so they can know how to perfectly apply it at home.
How have you seen people respond to
when you bring up an old lady who spent her whole life in farming in the soil, it's hard to convince them that this idea do really exist. But now when they see it, they become so excited to try it by themselves.
Everybody gets a kind of a starter kit.
Yeah. They all got all the starter kits, and they take it back for them for home, so they can start their own.
There's a lot of interest. It's quite crazy.
It's spreading so fast, and everybody is getting so interested. They used to farm a lot back in Syria, and they're looking forward to have it again.
It's a brilliant idea. Naturally, I like growing things. Now in my home, I have a garden. It has a lot of benefits.
What's your favourite thing about this project?
Having the old ladies so happy for having their home green again and feeling so comfortable. Teaching something new for the new generation to have their sustainability in the future in case anything bad happens.
More than 1,000 people have learnt this technique now, so we're just on our way to meet someone who is now growing food hydroponically in his home. Hamadi Waffles. Nice to meet you. It sounds like the garden has made this more of a real home. Is that fair to say?
Yes, absolutely. It makes me feel like I'm in my home village back in Syria.
How much pleasure do you take from the actual growing of flowers and vegetables?
Very much. I dedicate all my time to my garden. about 2 to 3 hours in the morning and 2 to 3 hours in the evening. So 5 to 6 hours every day.
Oh wow, your home is full of lovely green things.
The more the better. Growing things, being productive, it's very important to us.
It's beautiful. I mean, it's like a full garden you have here.
My whole family works with me on this. Their hands are with my hands.
Oh, they all help you garden.
Now they're even enthusiastic than I am. It's good they learn.
That's brilliant.
This knowledge we can share with our children, so one day they can benefit from it and share it with their own children.
We've learned as much back in Sheffield in our research from what's been happening here as the people here have learned from us. We just kind of gave them one thing and then they made it flower, forgive the pun, to so many things that have benefited all the research we do. We'll be taking learnings from here that in a suboptimal environment to optimize for high yield and low water use and low nutrient use and low energy use.
Do you mean what's being done here with old mattresses could be kind of an innovative step for urban agriculture around the world?
Yeah, and if you can make it work here, you can make it work anywhere.
So this is lunch in Battery. That salad was all grown in the hydroponic garden here, and it's delicious. And then some pizza from the mouthful. You have OBE, prof. How important is this work and in the context of that whole career?
I think when I retire and I look back on what I've done, the thing that'll stay with me most is this.
Oh, mate. Sorry.
I've done all sorts of things in my life. I've worked on synchrotrons, neutron scattering facilities. I've been in CERN. But the thing that I think I will treasure for the rest of my life is the difference we've been able to make to people's lives with a tiny little bit of science and a whole load of local ingenuity.
So I hope you enjoyed that. It kind of still gets me every time. So this is my mate Abu Wissam, and he's my mate Abu Wissam. He's about my age, and I had him in a compartment that was. There's a guy who was happy at his work because he keeps on sending me all these thumbs up WhatsApp pictures. He even let me ride his bike from the greenhouse to lunch. And he always has something new to show me. So they'd reproduce the way that lettuces are grown hydroponically on a floating bed, and you saw some of that in the film. But being there with the film crew exposed me to something that I'd ignored. It got me out of the compartment. And the film crew wanted to go to his house, and he took them. They didn't actually use the footage, but whilst we were there, it made me realise that he's a dad like me. He has a wife like me. He has 2 daughters like me, and they're about the same age as my daughter, and they live in a container. The kids have no hope for the future. It absolutely killed me. I went back to the hotel room and I wept all night. Rang home. That's why you saw me beefing in that film. So during lockdown, Zattery went into bloom. The refugee camp is in Jordan. Jordan essentially implemented martial law, implemented defense laws. It's surrounded by guards, and no one came in and no one went out. Consequently, they've not yet had a case of COVID-19. But they have had lots of mint tea and plenty of strawberries from the hydroponics. And this is the big showcase hydroponics that for when international visitors can come in, they'll be taken to the cafe that basically grows its own food inside the cafe. And like you heard in the movie, you know, we're doing urban farming. So what we learned in the refugee camp from them building things out of drain pipes, we implemented in a disused school out in Tinsley. And then when lockdown started, Moed had just started a growth trial. So he had 96 tomato plants that he was 3 weeks into a 3-month growth trial to look at yield and nutritional value. And we had to take the experiment down. So Moed was pretty cut up about having to throw all these tomato plants away. So what we arranged to do was we shared them out amongst the team and took them home. So I brought home a dozen tomato plants, and you can see the pictures from the 20th of March. I went into the lab and got some blocks of foam. I put the starter blocks into a big block, which is what they do in a hydroponic commercial greenhouse. I bought some big plant pots to put them in, and you can see the photo last week of tomato plants that are full of tomatoes and actually are suffering from a bit of heat stress, because my greenhouse, otherwise known as a conservatory, is rather efficient at retaining heat. Like I said, the best thing about this project is you can make your lunch out of it. So I will be having lunch that features herbs grown hydroponically in polyurethane foam, and tomatoes grown hydroponically in polyurethane foam, and lettuce grown hydroponically in polyurethane foam. I've never done any gardening in my life. Lockdown's turned me into a gardener. And right at the beginning of lockdown, the UNHCR got in touch with me and said, we have no PPE. Can you help us? So I put Pete Mylon in touch with the guy who runs the makerspace in the refugee camp, because they have a makerspace. And they exchanged files, and they started making their own face shields using the University of Sheffield and lots of the people who are on this conference's technologies. We got them making masks pretty early, and we had quite a lot of experimentation about how to make gowns by heat sealing that didn't quite work, and that's research. Then it kind of went quiet, didn't know what was going on. And when that happens, generally, it's two things. Either they've lost interest or they're just doing it. It turned out they were just doing it. So we repurposed the things we'd started with Zatari to look at providing people's PPE from the maker community in the UK for our NHS and, more importantly, care homes. And then the GCRF Newton Fund had a call for what was called Agile Response, and we had something there ready and waiting to go. We'd made a previous GCRF proposal that wasn't funded because, like the referees had spotted, all we wanted to do was help people. We didn't really want to do research. So we made this a bit more social science research, and I think we're going to learn a lot out of the high population density community that start to use PPE, because as soon as the borders open, they will go immediately to community transmission, because 80,000 people live in 6 square kilometers. So we'll be using the digital printing facilities that they have. We'll be using their sewing capability to do face shields, masks, other shields and gowns. I have a bunch of PhD students sponsored by Unilever and other companies in the personal care area. We're linking up with a firm called Givaudan, who've put a lot of money into soap production in the refugee camp to implement some new low-cost, low-tech hand hygiene solutions, and to use the makerspace to build robotic hand hygiene solutions, because that provides aspirational, educational aspirations for younger people. So this interdisciplinary course production project was announced on Saturday by the minister, and our leader in makerspace, Pete Mylon, is an intrinsic part of that. So I hope I've showed you how our journey. It started in making before I knew we were making. We did loads of low-tech recycling in Zattery that then we brought home to Sheffield, and it's led on to all sorts of other applications. So thank you very much for your time.
Thanks, thanks, Tony. Hope you'll agree that was absolutely awesome. Yeah, it's I knew some of the work that Tony had done, but I think seeing those videos particularly just really brings it home. Yeah, it's just really, really inspiring. Do we have any questions for Tony? You can either stick something in the chat, or you can use the raise hand thing, and hopefully we'll look out for it. Give it a minute to see if people can find the technology. While we're waiting, Tony, I was going to ask you, what was I going to ask? Oh, it's gone now. One thing was, what are you feeding the plants with in that water then? And where do they get hold of that?
Okay, so that's quite a laugh, in a sad sort of way. I've just put up the Just Giving campaign post for the desert gardens in the chat. So what we're not allowed to do is we can't give out solid fertilizer, okay? Because sadly as the people in Beirut found out, you can make an enormous bomb from solid fertilizer. Yeah, so we give out fertilizer that has phosphorus, nitrogen, and potassium in liquid form. In concentrated liquid form, so the refugees can dilute it. Basically, if you've ever grown tomatoes in the UK, what they're getting is Tomerite, or what's the other plant food called? The kind of plant magic or whatever. So it's standard fertilizer, and actually we tune it for the local water quality. So the water is actually a little bit salty, has high mineral content. So you have to kind of tune the fertilizer solution so that the plants can take it up. Miracle Grow. Thank you, Alison. Yeah, I'm a Tomerite man myself, hence the T-shirt.
Nice. To bring it back slightly to the sort of, I guess, to applications for people here, how what kind of lessons are there from the kind of co-working, collaborating with people on the ground? What kind of lessons do you think we can bring back to, collaborating with students and with local communities and things in the UK?
So I think that kind of the thing that I get told most of all about the way we work is that we're prepared to admit we don't know. Right. So if you go into a collaboration, on an equal footing with whomever you're collaborating with, that I have some answers, but I don't know all of this. Yeah. And I really want to learn. We can learn together. And for me, that's the most enduring thing. If you go in with a power dynamic of I'm the expert and I'm going to tell you everything, and don't answer me back and only speak when you're spoken to, you're going to get nowhere. So making sure that kind of interaction is honest and open.
Thanks, that's good. There's a question from Erica there. Can you see that?
Yeah, okay. So Erica, my first trip, was there's nothing growing in the ground because they're not allowed to grow things in the ground by Jordanian law. If you plant things in the ground, then you own stuff, then you own the ground. So that's why we were, and if you put up permanent structures, you own the ground. So that's why if the refugees buy themselves a wind turbine, the police come and tear it down. If Patrick Fairclough builds them a wind turbine that looks like shit, that's not a problem. They can keep that going because that's not, in the eyes of the Jordanian police, a permanent structure. So I'm there, and the other thing is being culturally aware and culturally adept. Okay, so I'm saying to the UNHCR people, look, you've got 80,000 fertilizer factories here that are called refugees. So if you were to collect their excrement, yeah, that's full of nitrogen, phosphorus, and potassium, and you could use it. Erica, it's an absolute no-no. I mean, the disgust on people's faces, it's just unbelievable. So I've actually stopped even suggesting it. So 100 years ago, no piece of no piece of shit went wasted, right? You know, everything was good to be used as fertilizer because we didn't have enough fertilizer. And I think the UK is going to end up collecting human waste and using it on the fields again. Yeah, I've even tried encouraging people to let the kids wee in the hydroponics because you have to dilute it, but
Great. Okay, oh, there's another question there.
Toxic effects from polyurethane. The isocyanate has all reacted. There's immeasurably low isocyanate levels in a polyurethane foam. The dangerous things are the tin catalysts that are used, and we checked to make sure that no tin catalyst used in the formation of the foam came through the plants and into the fruit and leaves, and we really did check that. There are also problems if you use recycled mattresses in countries that allow brominated and phosphate fire retardants, that you'll get some of that coming through. And again, we've not been doing things on this scale in the UK, but we are looking at always looking at what comes out of the polyurethane foam and does it end up in a plant.
Fantastic. All right. Well, thank you so much, Tony. That's been really illuminating. Yeah, Tony's put the Just Giving link there. But I'm sure if you wanted to contact Tony and ask any more questions, he'd be up for that.
More than happy, yeah.
Okie doke. So next up, I believe it's me. Right. Let's see if I can get this technology working. Okay. How's that looking? Okay. So, yeah, sort of following on from what Tony's been talking about, he mentioned a little bit towards the end there about what we were doing with PPE, and I'm sure lots of you have been involved in that in various ways. So I just thought I'd kind of do a bit of a summary, really, of what the Maker response to COVID-19 has been. If you know a lot of this already, then sorry, but hopefully it'll be interesting for lots of you. Okay. So very suddenly in March, we all rushed out of work, leaving our belongings behind us. In Sheffield, as I was elsewhere, wasn't long before the calls started to come in, primarily from students, wondering what we could do to help sort of alleviate the situation. But anyone who works in higher education knows how seriously universities take health and safety, and the building. So the building was closed. End of story, really. But people kept pestering me, and if I didn't know for an answer from the uni, then we wouldn't have had the iForge in the first place. So I decided to do a few things. I started a Slack group called Makers Against COVID-19. And this is a really good way for people to throw around ideas and share what they'd found that others were doing around the country and around the world. And at the same time, I started to talk to medics to find out what the need was. And Sheffield's blessed to have links with Sheffield teaching hospitals via the medical school at the university, so we were able to talk directly with them and to their innovation team. Amazingly, the hospital actually has a workshop, which I'd not discovered until this point, but they've got 3D printers, they've got a laser cutter and welding kit and all sorts down there, which was great. So they were able to sort of join in with the effort of innovating and prototyping. And so at the same time, I've seen some calls on social media for people to provide PPE. So I decided to put out some feelers to local GPs and see what they needed. Overwhelmingly, the answer that came back was we need visors, we need face shields. Although people were becoming aware of the possibility of infectious droplets reaching the eyes, healthcare staff were only being provided with masks, and they were getting seriously concerned. I spoke to a practice manager, and she was almost in tears on the phone. This was sort of when the first reported medic, as an ENT surgeon, I think, had died from this, and they were really worried about the effects on their staff. And there were also some serious issues with the NHS supply lines at the time, which are well documented in the news. Most of the manufacturers of these kind of bits of kit's been taken out of the UK, and so unsurprisingly, there are issues with getting shipments in from China and things during as soon as everything just shut down. Even some of the shipments that were organised weren't fit for purpose. You'll probably remember there was a whole shipment of PPE from Turkey, which was then deemed not to be useful, and so there was a real kind of crisis there. But what I did was took the requests from local medics to our head of engineering, Mike Hounslow, and he was actually really supportive. He said, let's kind of test this out. We don't know how much demand there's going to be, but let's see. But actually, the same day, he received a request from someone else who'd been in contact with a medic, saying, "Oh, doctors really, they really need face shields. Is there anyone that'd be able to make these?" So it was, so it was really good timing. Before I knew it, we were opening up the whole of the Diamond building, rounding up volunteer staff, commandeering printers from across campus, and ramping up production. And this was all actually within a week of the shutdown. I went back as I was preparing this to look at the sort of timeline and realised how quickly all of that had happened. But the thing is, that's how fast universities can move when they have makers providing the momentum. In fact, university makerspaces are in a unique position in having the innovative, agile culture of makers, but also having the resources of a large organisation. As I was exploring what we could do, I started to see other networks spontaneously coming together, primarily on Slack, such as the Masks for Docs group, and then I discovered a UK group called 3D Crowd, which at the time was a loose group of makers with access to home 3D print who'd come together with a desire to make face shields. Even this early on, makers across the world had come up with different face shield designs, and 3D Crowd were using one of the most popular, which was designed by Joseph Prusa. You can see here in the photos. He runs a 3D printer company. They have a factory full of 3D printers that make 3D printers, and we have a ton of them here in the iForge. They're really good piece of kit, actually, worth checking out. It only costs you about 700 quid, and you can buy a kit printer that's easy to put together, and they're really nice quality. So he was really one of the people at the forefront of that. He's based in the Czech Republic, so he worked with the Czech Health Ministry to produce this design for a face shield that was sort of government approved. But the thing about 3D printers is they're cheap, and you can find them around the home a lot, but you can only get as far as producing the headbands. You can't then produce the clear visors on there. You can't organise distribution, properly disinfect everything, organise bulk orders, materials, manage requests, create appropriate software to keep track of orders. If you're just a home printer, they needed was others to do that for them. So 3D Crowd actually linked up with Pimoroni, who are a company just down the road from here, who make electronics, and they organised all the distribution nationally for 3D Crowd, which was great. So for Sheffield, it was a real we were sort of really at the centre of things, which was fantastic. But at the university, we found that we could do all of those things. We had laser cutters, so we could cut the visors out to go onto the 3D printed frames. We have a chemical lab and a bio lab, so we could do all the disinfection and autoclaving, clean working. We had accounts with suppliers who could come and deliver us bulk materials, and we've got stores and a whole system to get that in bulk. We've got students and staff with IT skills who could jump on and create systems to make all of our ordering processes run smoothly. And we've got a whole fundraising department as well. So we also ended up with a Just Giving page, and we brought in over £20,000 in donations for materials. We even got a delivery driver in from estates. So we were in quite a unique position, and we ended up being the coordinators for South Yorkshire. And we made about 8,000 face shields by the middle of July. I've got a little video summary here that we made of the process for an outreach event. I think I've just done the one thing that I wasn't supposed to do and not shared my sound, so I might just have to reshare. Tip for any presenters: remember to tick the little box that says share audio if you're going to do that. Okay, let's see if this is going to work. If you can't hear this in a second, then do let me know.
Engineers at the University of Sheffield have been making face shields for the nurses and doctors to protect them from the coronavirus. They use special machines called 3D printers to make the headband, the part that keeps it on your head. There are 23 3D printers running at the same time in the Diamond Building, the university. Lots of other people around are also doing this at home with their own printers. As soon as the printers are finished, the headbands are cleaned and the engineers add elastic bands to keep it on. They use a laser to cut out the see-through plastic shield that goes over your face. All the parts of the shields are taken to the cleaning lab to be washed with chemicals. The side of the shields are melted and bent to make the shape. Then they cool off. Finally, they're put together and finished. Every day, they count the face shields to see how many they've made and write it on a board. Then they label them to be sent to the right places. The next day, a van delivers them to all the doctors and nurses around Sheffield.
Now, I know that we're not alone within education and being involved in PPE manufacture. Paul Watson, who's here somewhere, sent me a great report on what they've been doing at Newcastle. And even in Sheffield, there are a team of DT staff at local schools who made tens of thousands of shields from laser cut polypropylene and gave them to the local hospitals. In the US, our friends from the Invention Studio, if you were here last year, you might remember Craig Forrest, who did our keynote speech. Students there at the Invention Studio designed another laser cut version. Interestingly, we actually moved over to a laser cut design in the end. If you use 3D printers, you'll know that they're not really suitable for large scale manufacture. They're slow and expensive when you get to that kind of scale, and it's much more sensible to injection mold the headbands. Then you can bang them out at speed for a fraction of the cost. But what 3D printers are is flexible and widely available. People stuck in lockdown could still access them, and they allow people like Prusa to develop and iterate their design in response to user feedback in an incredibly short time. Eventually, the big boys got the injection molding up and running, but it was the makers who were quickest off the mark. The one area which is an exception is the hand sanitizer. A lot of companies were able to switch their production quickly, gin makers, cosmetic companies, and so on, because it didn't require a big change in setup. Use the same processes like bottling and alcohol production and so on. This was supposed to be a little GIF representing the sort of inertia of industry as opposed to the quick acceleration of the makers. So what else have makers been doing during lockdown? So many groups of textile makers sprung up, making scrubs, masks, caps, scrub bags. Why was that something that was so common? I think, as with 3D printers, sewing machines are, well, even more widely available at home, and the patterns can easily be shared. Some of you may have sewing machines in your maker spaces. I think sometimes as engineers we tend to overlook the textile side, but it is actually it's a really important part of making, and it does really it does blend well with the engineering side of things and allows us to do a lot more. There was also an effort to make transparent masks to help lip readers, which I think was a great idea. There were some challenges there with avoiding the plastic misting up. I certainly didn't manage to come up with a solution, but I'd be interested if anyone else got anywhere with that. So ventilators, big thing in the news. There was a government call, and in response to that, lots of collaboratives created ventilators. We had Formula One teams doing it. Dyson was a sort of well-documented case. In the US, MIT came up with this event, and in the UK, we had universities collaborating with industry on the Oxvent. So that was Oxford and King's College London, and then Smith and Nephew. Fortunately, most of these haven't been needed yet, but they're really good examples of that sort of agility in design and prototyping that makers can have. I particularly like the Oxvent, where they deliberately used parts from the NHS supply chain that were less in demand, so that it wasn't going to impact on the existing ventilator procurement. Makers also used 3D printing to replicate parts of the ventilators for existing machines. So in Brescia in Italy, the 3D printing company found that ventilator valve suppliers were unable to keep up with demand. So they went away, made a prototype in 3 hours, and printed 100 valves in 24 hours to supply this hospital. The same designers were then contacted by medics about creating CPAP masks that aid breathing in less intensive situations. And they worked with the medic whose idea it was, and with Decathlon, who supply these full face scuba masks, to create an adapter that could connect the mask to the breathing apparatus. This was another great example of industry being willing to work with makers and sharing their designs for the greater good. AMRC joined in and collaborated with Airbus. Fantastic. Yeah, so it was, AMRC is a great example within Sheffield of that kind of university industry collaboration, and they were very much a part of what was going on, which is great. They've got some fantastic technology and some great brains down there. I've seen we've got a few AMRC guys on the line here, which is great. So various groups also created 3D printable ventilator splitters, which allow more than one patient to use the same machine. So it's another way of solving the kind of crisis of not having enough machines that we thought we were going to be in. So these included engineers at Johns Hopkins University, which is what you can see here, and also a team from the University of North Texas. There was lots of discussion about how safe and useful these could be, but it showed at least the kind of mentality that there was at this point, that such a solution would even be considered for clinical use. For anyone that's worked around the medical sector before knows the kind of challenges with getting anything like this approved in a normal situation, but it was definitely a case of desperate times. These examples do highlight the issue of regulatory compliance that's been a constant challenge throughout the pandemic, and different people have taken different approaches to that. Some just said, well, people will see that we're trying to do a good thing, they're not going to sue us. It's the sort of ask forgiveness rather than permission approach. Others refuse to touch anything that could be considered a medical device for fear of litigation. And then there were sort of various shades in between. So with that scuba mask we saw, they asked people to sign a disclaimer agreeing that they were using an uncertified medical device and sort of taking responsibility for that. At Sheffield, we've so far steered clear of medical devices, really, mostly because there seem to be plenty of other things that we can do usefully. And I think if you are going to do that sort of thing, you need a strong clinical lead and a lot of support on getting through on the regulatory side. But some of these institutions like Johns Hopkins and so on will have a stronger track record in medical device innovation, and so they were able to make that step. One thing we did look at in Sheffield was these nasal pharyngeal swabs. As we all know now, testing is a big pillar of the COVID response, and it took them a while to get up to speed with that. So in Spain, this multidisciplinary team, they had ear, nose and throat specialists, microbiology specialists, nurses, engineers. They found a way to 3D print these nasopharyngeal swabs using Formlabs printers with biocompatible autoclavable resin, so that they could be sterilized afterwards. Again, using 3D printing meant that they could iterate incredibly quickly. They arrived at a final solution within 10 days. And it also means they can make with these Formlabs printers, they can make 650 of them in 24 hours on a single printer. So they do offer that kind of a bit more speed than perhaps some other 3D printing technologies. Formlabs then became involved in the effort, and since they were loaning us a Form 3 at Sheffield, we did think about getting involved. But interestingly, the response from medics was a little bit mixed here. There was concerns about various aspects of sterility and things like that, whereas in the US they seem to have been used really widely. Electronics and computer science researchers at the University of Southampton helped to develop this personal respirator with the aid of engineers, medical staff and industry partners, and that allowed medics to have a bit more confidence in the level of safety that they had going into a COVID environment. So it's another great collaboration. You might have seen these aerosol boxes. Intubation when you've got breathing difficulties is a common procedure, and it's what they call an aerosol generating procedure, which was the things that they're kind of most worried about in this situation, where you're actually basically getting sorts of spit and fluids coming out, which could well be infectious. So people created these boxes that they could still do the intubation, but it sort of shielded them in the same way that a face shield might do. There was a lot of uncertainty early on, really, about where to focus the efforts. I've already talked about the medical device regulation minefield, which wasn't helped by the constantly changing landscape of government advice to manufacturers. You can see here, this was some documents that we were sort of working off for small scale manufacture of PPE, and you can see the number of iterations of that within a short period of time. So that made it challenging really to know what was acceptable, what we should be doing at this point, because the government didn't really know, and they had to change a lot of rules. But there was even the issue of how this virus was transmitted and how best to combat it. So some people focused on indirect contact transmission, such as using door handles, but I have to say I haven't really seen these kind of these things take off hugely. Others like us focused on droplet transmission prevention through face shields, and others focused on airborne transmission. So as well as the air purifiers, there were attempts to make proper particulate filter respirators. So these were a little misguided. This one uses a copper infused filament, since contact with copper is supposed to kill the virus faster, but the levels of copper within the filament are quite low from what I understand, and the particles are going to be embedded in plastic, so I'm not quite sure on its effectiveness really. I think we also, generally people had sorts of doubts about what individual makers could do. It's a sort of, this is a massive global pandemic, what can I do as a small person compared to like a big multinational company and all of their resources. But I think actually when you look at things like the 3D Crowd initiative and the way that makers did come together nationally and internationally, we can kind of see how that worked out really. So what can we learn from the response to this crisis about what makers do well? For me, the main thing we have going for us is agility. Compared to specialized manufacturers, makerspaces have a much wider range of equipment, which allows them to make most things and adapt quickly. And we also have this culture of innovation. Makers are used to problem solving and to taking an approach that says, how can we do this differently? And makers have also embraced digital technologies like CAD/CAM, 3D printing, cloud-based working, Raspberry Pis, and so on, that allow the process of design, prototyping, verification, and iterative improvement to be massively condensed so that completely new products can get to the end user at a pace that's unimaginable a generation ago. We also have community. This is particularly true in higher education. We can bring in perspectives from both first year students and heads of faculties, pro vice chancellors like Tony, and we can tap into expertise across a huge range of disciplines, particularly when we collaborate across the sector and with industry. And this is one of the reasons I started UNIMAKER. As a great poet once said, it's always better when we're together. And makers are also great at sharing their insights through open sourcing. There have been so many great examples of this during the pandemic, allowing innovations to be replicated around the world rather than reinventing the wheel. So here's just a little example of an interdisciplinary project that I've been working on recently. So this is a project called Care Sleeves. You can have a look at this website. If you go to caresleeves.co, you can sort of see what we've been doing. But essentially, this has been about making garments for care homes. So, as we know, care homes have really borne the brunt of COVID, and so yeah, there's very much, and I think to some extent, care home workers, there's certainly been a perception that they've been overlooked compared to the NHS, and we wanted to do something that made them feel protected. So we've been creating these garments, and this has been a really fantastic example of an interdisciplinary team. We've got engineers, we've got materials scientists, we've got manufacturing textiles experts. The whole idea was started by a costume supervisor at the opera, So it's yeah, and we've got laundering companies and all sorts of people involved. So it's been really great in that respect. And yeah, we're still. Tony mentioned earlier, actually, my very first efforts with the gowns we were trying to sort of use modified soldering irons to melt some bits of plastic together. We've come a long way since then, but we're still not quite at a point where we've got something that can be used. And as with everything in this pandemic, it's kind of this rush to try and get things out before any perceived second wave. But it's been a really fantastic experience working with this team, and hopefully we'll be able to produce something that will be useful for care homes. So yeah, keep your eyes out on that. Okay, so before I hand over to our last speakers for this session, I'll open up the floor in case anyone's got any questions. Or if you want to share with us anything else that you've been doing in terms of making PPE and things, that would also be great. Do we have a link to the laser cut shield? That was a good question. I can certainly send it to you. I don't believe we've put it up online. I sent it to a few people. So we ended up, we took a design, basically the Prusa design, which is 3D printed. So those are the ones, one of the most common designs that you'll have seen everywhere. Somebody rehashed that as a laser cut design. We then took that as a basis and sort of modified it a bit. So basically, it's you use two sorts of straps of laser cut plastic and you rivet them together. It did take quite a lot of iterating to get that one right, trying to get even the heat settings on the laser cutter right so that it wasn't too brittle. We were trying to get material in at the from wherever we could find it, because everybody was running out of plastic at the time, and some of the supplies that we got were terrible and brittle, and yeah, it was quite a challenge. But certainly, yeah, if anyone else wants me to share that file with them, I can do that. How did you find the government guidance during this period? Alice, did you mean how did I come across it, or how easy was it working with it? I'll address both of those, I suppose. But yeah, so there, this website that I showed, they were posting things up, and we're on, I don't know what iteration we're on now. As I say, they keep sort of churning these things out. And at times they'd sort of have I mean, I think the worst thing was their kind of definitions of, we were sort of, where do we fall into this? Because we're not making a profit out of it. We're not some, are we a large scale manufacturer because we're doing quite a lot of these? Are we a small scale manufacturer? Are we volunteers? And where do we fall into that whole thing? I think that was kind of the challenge, really. I think generally with the face shields, we felt like we weren't straying too close to the medical device stuff, and therefore I didn't see any huge risks in what we were doing. I think it does get a lot more complicated if you're trying medical device regulation. So the government did set up this, there was a sort of a board where you could basically, if you wanted to manufacture stuff, you had to sort of apply to this board and say, this is our idea, and they would review it. But it didn't seem hugely agile in the situation. It didn't seem like there was going to be any quick response. I think a lot of the time people just sort of did go with the, well, let's just get on with it, because this needs doing, and we'll deal with the consequences later. Yeah, I know a few people did at some point stop when the advice changed. Yeah, I wouldn't want to be in their position, but at the same time, I don't think it was kind of brilliantly handled. there were, a lot of early calls out for, we really want manufacturers and makers to do this, but then a lot of the time it felt like they were just putting hurdles in the way of people actually doing it. There was somewhere where you could sign up, but I think at one point they had a lot of people signed up to say they could manufacture stuff and then weren't ever really made use of. As I say, in a lot of ways we were lucky that with things like the ventilators, they haven't as yet had the huge demand that they expected, and so that left people like Dyson in a difficult situation where they'd spent this time designing a ventilator and then were just told, oh, we don't need it anymore. But yeah, these things it's very difficult in these kind of developing situations, and most of us had never been in a position like that before, I guess. Okay, any more before I hand over to our last team of speakers? Great. Okay, so we've got Thomas. We've got a team of students from the Bionic Society who are going to share a little bit about the work that they've been doing. Hopefully, yeah, Thomas is now a presenter. So if I stop sharing, Thomas should be able to share. Thomas, I'll leave it to you to introduce the rest of the team if you like.
All right, thank you, Peter. So I'm here today with Alex Pop and Nicholas Hadis, who are part of the society, and Alex will introduce all of us as we start. Let me just share my screen. Share audio. Thanks for the tip, Peter.
Hello everyone. So I'm Alex, as Tom said. I'm the president of Bionic Society, and together with Nick, which is the previous year's president, and Tom, who is the prosthetic arm team lead, where we make up part of the prosthetic arm team here at Sheffield Bionics. So by the end of this presentation, hopefully you should know a little bit more about the society, what we aim to do, and how we went about achieving this remotely post-COVID. So we're a group of students who are passionate about bionic technologies and the impact that it can make on the lives of people with disabilities. So the Bionic Society basically aims to improve the quality of life of amputees and other mobility impaired individuals in the UK by either providing prosthetic limbs or creating a brain-computer interface controlled wheelchair. So basically, we allow our members to use the skills they've learned from their classrooms in a real-world setting. So it's either improving their circuitry, their 3D design, or their manufacturing. Everything gets used. Most importantly, we basically create a network to share knowledge gained from one person to the next to achieve quite a nice goal in the end. So the society is made up of 3 main sub-teams: the arm team, the leg team, and the brain computer interface, or BCI team. Sorry about the delay, I think. This year, the society has also started Bionics Bootcamp, which basically teaches newer members key skills, so like Arduino, Fusion 360, and Python. So we basically, by doing this, we hope newer members are engaged and also encouraged to join one of the 3 main teams. I'll hand over to them.
In April, we found Mark Whitehead, our amputee, through Facebook. And he is the founder of a non-profit humanitarian organization in the Yorkshire region. And we have a quick video from Mark on him and his perspective.
Hi, my name's Mark Whitehead, right arm amputee. I'm a crisis intervention specialist who works with a humanitarian organisation called HC20. I currently have a prosthetic, which virtually enables me to walk activities such as climbing, Having bionic arms means so much to myself. It would remove so much anxiety and stress that I have through daily little tasks such as washing my bread, slicing a loaf of bread, putting toothpaste on the toothbrush, and eating tiny stress. Whilst everything else that I do, my daily tasks include caring for my mum, doing the household chores, doing cleaning, day-to-day care stuff. Having bionic means so much to me, changing my life.
I think one of you needs to, oh, okay,
just
it's all good. Yeah, I think one of you we needed to mute your audio then because we were getting it twice, but it's fine.
Okay, sorry about that. So from this quick video from Mark, as you may know, that simple things that we take for granted, like tying our shoelaces, seem difficult for him, and things that he used to do before his amputation, like kayaking, hiking, are almost impossible. So we wanted to change that, and we wanted to make something specific for Mark. So the first thing we did was to go to Mark and have a chat with him and ask him about the specific problems that he is facing with his current prosthetic. Just for information, this interview is there in its full on our Sheffield website, or Bionics website, that you can find for those who are interested. So there are two. Now let's go into the ways which Mark interfaces with the arm. So the first way would be through the socket, which holds his arm. And we asked him about his problems, and one big thing he complained about was having phantom pains after prolonged use of his current prosthetic. It's mainly because his current prosthetic is an adaptation of a common leg prosthetic, meaning that the fit isn't perfect, giving him these phantom pains. So what we did was we took about 800 pictures of Mark and his stump, and we then took it into the computers and modeled the stump using 3ds Zephyr and Blender. We then created a stump. We then created a socket around that stump using Blender, and then printed it and met up with Mark again to check for his feedback and make sure that everything fits well, and we could so that we know where to alter to make that fit even better. And here's a video of the stump that was created using 3ds Zephyr and Blender. This is what we used to make the socket from. The second way that Mark interfaces with the arm would be through the myoband, which is a series of 8 EMG sensors that detects the electrical signals from his arm. And then we first try this on ourselves. As you can see, that's the white band on my hand. And then we collected data from this and shoved it into a machine learning algorithm that we created using Python. From there, this allowed us to have real-time gesture mapping, which I will demonstrate in the video. As you can see, I'm clenching my fist. The myoband detects that I'm clenching my fist, sends that data into the program, and then it outputs the fact that I've been clenching my fist. And we've started collecting data with Mark, so the same thing is going to be happening with him. Now I'll hand it over to Nick.
Hi, so I'm going to be talking a little bit about the mechanical design of the rest of the arm. We're pretty new at this, and we've done a little bit before, but we're kind of excited about what we've managed to come up with so far. So hopefully you could see the two arms. I'm not sure if the PowerPoint's lagging behind or not, but there's two arms right now that we had done previously before the summer, which were open source designs. So the one is the in-move hand, and something that we didn't like too much about it was that it wasn't very compact, and it was really hard to string up to act as the tendons. So we weren't too happy with that design as an open source design. Or the Brunel hand, which was pretty interesting. All the motors fit in the palm of the hand, but it was very expensive and wasn't very reliable. So we decided to come up with our own hand and design the whole thing from scratch. Let me know if you could see the arm slide, because it hasn't updated on mine. You keep on speaking though. So yeah, it seems frozen. Tom, do you want to try unsharing and sharing again? The screen.
All right. Can everyone else see the arm? Okay. Let me unshare. Stop sharing. Nope. Share the application screen, the entire app.
So basically, what we've been trying to do is take what we've learned from previous years and then design our own one from scratch that would best suit an amputee and also allow for the prototyping process to be very easy and allow us to change a lot of things. So Tom, if you want to go back to the previous two arms, quick. I'm not sure if it's still, yeah. So these are both open source arms that we 3D printed and tested out ourselves. And then Tom, if you move on to the CAD model. So this is what we've been doing over the summer. And there's three main design aspects that we tried to include with this. One is compact electronics. So we wanted everything to fit neatly inside the arm. The next is better linear actuators and cheaper linear actuators. And the third is to make it super accessible to help with prototyping. So firstly, with the compact electronics, as you can see in the picture, there is a Raspberry Pi, which we plan on doing all our gesture recognition and machine learning models. We're going to put that on there to help control the arm and any other communication. And then directly beneath it is a PCB, a printed circuit board, that we designed and made ourselves, which can control the motors. It has 6 ports, and so we call it the hexadrive, driver. It's control 6, and then directly below that we have a battery as well. So it's all nested nicely at the back of the arm. Then at the front of the forearm, there are 4 linear actuators. And something that's special about our linear actuator design compared to the ones used in the Brunel hand is that it's a lot cheaper. So we brought the cost down from £60 per linear actuator down to £8 per linear actuator. So it makes it a lot more accessible. And we basically did that by repurposing a DC motor and creating a housing around it. We'll see a video of that a little bit later. And finally, the accessibility. So something we found with all open source designs is if you needed to go in and tweak something or change a couple components, something like that, it was really, really hard. You need to just assemble pretty much the whole arm. So we've decided to put a hinge on the side to open up a hatch, and all the electronics also fold out as well. So it basically makes everything a lot more easier to work with, and we could prototype a lot better. On the next slide, we should be able to see a video of the hatch opening. So we thought we might as well take the cool route, but it's probably going to end up opening up like a book on the forearm so that you can easily access everything. And there's also the linear actuator video, which it's basically just a DC motor and this is without its housing. So hopefully you'll be able to see if you grab the part at the end and stop it from rotating, it basically screws it up and down. And that could be used to pull the strings as if they were ligaments to actuate the fingers. So moving on, basically because Mark is an above elbow amputee, we decided to come up with a couple elbow designs. Still working on this and we're quickly deciding, but these are a couple of them just to showcase it. Some of them are direct drive, some of them use strings and basically get pulled strings. Then next up, so the big part with assistive devices is aesthetic, right? The amputee needs to feel comfortable wearing the device and feel proud of it. So we came up with skeleton and panel design. So basically what you could see there is what the skeleton would be. So this would hold all the electronics, all the motors, everything that you need to make the arm work. And then we decided we would be able to clip on panels to customize it. So if, depending on the amputee, what they would like, you would be able to print different panels and we would have the same base skeleton model. And then you could clip on these panels. And they clip on using a keyhole mechanism that you would see in like everyday doors. You could just slide on and lock in. So Mark, in our case, really wanted a Halo themed arm from the video game. So this is us starting to design the panels around it. So hopefully he'll feel really happy and cool wearing the arm. So yeah, and then I think moving on to the final, our next steps, right? So we've spent the summer designing a lot of the basic stuff, but something that we've still been working on now and we want to complete is a fully biomimetic hand. So what we did here is we took CT scans and we cleaned it up so we could get the actual bone structure of the hand. And then we plan on adding on that so that we could get lifelike movements and try and make it very close to a real hand. So we think this will be really cool. So this is what the actual hand might look like with a little bit extra and a couple more panels. Then we are working on improving our processing control. So that's cleaning up the data and making it better to get data collection for the Myoband, so we could get a better machine learning model to make sure that Mark could control everything accurately, as well as increasing our control system. So we want to put sensors in the fingertips so we could get force sense and a feedback loop. And then finally, we want to go on to create our Myoband. So this is an array of EMG sensors that Tom was talking about before, and that's a off-the-shelf one that we've been using. So we think if we create our own, one, it would be a valuable learning experience, and it would be cool to have an open source design of it so that other people could use it, because I think right now the off-the-shelf components are out of business. So this would allow it to be a lot more accessible for other people, and it would give us a lot more control of what we're gaining in terms of data. And then I'm handing it back over to Tom.
So as you can see, here's a video of the Biomimetic Hand moving. This is one of many videos that we sent to on our messenger group chat. Everyone motivated, and just to make sure that we still felt like a team, even though we were all spread around. And just as I mentioned before, we had to do all of this despite coronavirus and lockdowns. And it meant that everyone was all around the world spread, and we had to find a way to work together. So one big issue we had was having our funding cut off to be due to the current financial market. So this made us revert to crowdfunding. We were able to raise around £1,100, which gave us enough money to print all the components we've printed so far, order all the electronics, and work this far. And as a form of saying thank you to our donors, we all as a society ran 2 kilometers per pound donated. So a lot of kilometers. And to stay in contact, we used Messenger, as I said before. All of our files were shared in a shared drive. And we used the cloud services of Fusion 360 to store all of our mechanical designs, aided with the more fluid designs of Blender, Mesh Mixer, and 3ds Zephyr. We use GitLab for the firmware team to store all the code, so it allows both the hardware and the firmware teams to make sure that they have the most updated files of their own and their team members at any time. And we use Google Meet for our weekly meetings, which are scheduled using Boomerang for Gmail. We also started printing our test components, and we have started printing the socket, as you saw in the video before, and started printing the hands. But none of this would have been possible if it wasn't for everyone on this list. It was each and every one of their hard work that allowed us to do what we've done so far, whether it be students, which is the majority of this, or Sheffield University alumni who are willing to spend their time around work to help the students who are there and to teach those students what they've learned. And just to summarize, we told you about the society. We told you what we did over summer in building a bionic arm. And we told you how we managed to do this despite COVID-19 and lockdowns. And with that, we'd like to say thank you and ask if you have any questions.
Fantastic. Thank you, guys. So again, if you want to put any questions in the comments, or at this point, if you just want to open your mic and ask, that's fine. So you guys talked about open sourcing it. So you've obviously, I guess with these kind of things, there's a couple of different approaches in terms of either looking to kind of commercialize it so that it can become a sustainable thing, or going down the open source route. How accessible is it going to be for people, do you think? What do you anticipate when you've kind of finalized the design? Let's say I'm an amputee. How much is it going to cost me to make something like that, and what sort of range of equipment would I need to get access to?
Should I take that? Looking at cost, so far what it would cost would be around 800 to £1,000. It's all very dependent on the filament used in 3D printing, because most of our components are 3D printed, so you need access to a 3D printer. In terms of us making the files accessible, we plan on keeping everything on Thingiverse, so that an amputee would be able to go on Thingiverse, download the STL files, print them, and then start assembling them.
In terms of how much Mark has paid, so Mark at the moment currently has a very basic mechanical prosthesis, and he's paid £49,000 for, I think this is a 7th iteration, and all he can do is clamp onto things. So while £1,000 may seem like a lot initially, it's like 50 times cheaper than what is currently available.
Wow. Is he paying? Is he paying for that out of his own pocket? Then it's not available like through the NHS, or?
Because of his situation, so he's able to pay for it himself, but I'm not really sure I can say on camera, I'm afraid. But yeah, he is paying for that himself.
Yeah, fair enough. No, that's a amazing saving, and I guess it makes it more accessible. What do you think? I mean, how would somebody, if he hadn't come into contact with you guys, how would you how would people get access to things like the 3D printers and stuff? And how can we as makers kind of make those links with people?
So I would suggest that we've creating networks with makerspaces around Sheffield first, and then around the UK. So if anyone were to come into contact with us, we could obviously print it, but to make it something faster, we could probably work with makerspaces around the UK, or Sheffield in particular. So that would allow the components to get printed much faster, and then that would allow us to assemble them.
An interesting project we've been working on in collaboration with Actus is to basically use what we're developing here in the society and create hobbyist kits around it. Kit, and then maybe try help and work on the arm with us, or help develop their own thing. But this is still in its groundworks right now. But hopefully that would also sort of create a community around it. Yeah.
Great. Any other questions from the floor? Oh, thanks. Yeah, so Nick's put the link in the chat there. Yeah, it's worth looking at the website actually. There's some really good content on there, and as you say, you've got your other projects as well. If anyone's interested, it'd be great. Yeah, great to see these kind of things being made in other makerspaces around the UK and the world, as you say. Okay, well, thank you so much, guys. That's been really informative. 98% saving, yeah, fantastic. So again, yeah, I'm sure there's an email there. You can contact them if you have got any questions that you think of afterwards. So that is us done for our morning session. So we're back at 3 o'clock this afternoon, and we've got a session on co-curricular and extracurricular making. So we've got the team from Project Phoenix talking about a plane. We've got Alison is going to come and talk about Maker Fusion, which is a STEM project for primary engagement. We've got Richard talking about IoT, and we've got a keynote from Taylor Dixon from iFixit, who's going to be talking about repair, hopefully doing a bit of demoing, I think, as well, and sort of giving us some ideas about how to do repair cafes, and also just more generally about how to make engaging content for our spaces. I'm really looking forward to that, so hopefully you'll be able to join for that. It's going to be an early morning start for Taylor because he's over on the west coast, I believe. Yeah, but we'll hopefully see all of you there, and enjoy your afternoons. Feel free to hang around and to chat with people. As I say, the room will stay open.